Hey guys, it's Ferdinand Dandy once again of the DR 100 Watt Concept Project. This is a Class D power amplifier adventure, and in this video, I'm going to continue the adventures in discovering the Loto PC-based oscilloscope and its measurement automatic capability. I mentioned about the automatic measurement capability because this is very attractive to me as a DIYers. Just make sure that you watch the earlier videos in the setting up the hardware, this Loto OSC482 oscilloscope, as well as the audio signal function generators. That setup is necessary to understand the measurement capability of the OSC 482 oscilloscope. Alright, let's dive to that. Now that I'm going to use the oscilloscope probe, there is another extra setting that I need to do, and that is the setting for the probe X1 or 1X and the 10X. So this setting actually is needed in the software as well as in the oscilloscope probe, that if you know the voltage that you're about to measure is within the range of 5 volts, then you can use or set the oscilloscope probe to 1x and also the software to 1x. However, if you don't know the voltage that you're about to measure, then it is safer to set the oscilloscope probe to 10x also in the software. This will prevent from possible damage if the voltage is too high. Just remember that at 10x, the maximum voltage will gonna be 50 volts. Now, there's another thing to do since we're using the oscilloscope probe right now, not just like the BNC. I would like to stress and emphasize that you need to do a calibration specific to that oscilloscope probe. What I mean is that probably need to adjust the oscilloscope probe by compensating about the loss of frequency or the gains of frequency or a specific frequency. For this oscilloscope, they have a kind of calibrators that you can use it to check the oscilloscope if the probe is reading the correct frequency as well as the correct magnitude or values. For this demo, I'm going to use the audio signal generator, which I'm going to demoing the sine wave, which is generally targeting to be used in an audio amplifier. You know, sine wave is generally used in audio power amplifier electrical performance test. Alright, so with all the setup in the past video, once you click or enable the audio generator, turning it on, you may see a signal on the oscilloscope screen. Find the set or SETT, which probably this is the short name for setting. Click it and it will take you back to the oscilloscope setting. Then you're going to find the auto, this one in here, and click it. This will going to automatically find the best time base and also the best amplitude setting, so it can be displayed well on the oscilloscope. And there you go. It's like magic. It's like easy as 1, 2, 3, and you have now the sine wave display on the oscilloscope. Let me set the output to be 1 volt RMS. Again, this can be set on the signal generator module, like what I'm doing it right now. Now, let's move the mouse, which is have a cross point. If you navigate the sine wave at any point in the waveform, there is the magnitude indicator, which is in peak or peak to peak. I can navigate to any point in the signal and can get the signal magnitude. You can see that there is a kind of magnitude being displayed in there. This is awesome, isn't it? So if you see at the bottom of the waveform, You will find here the channel A, which means to say that the channel A magnitude, like maximum, minimum, the peak-to-peak value, the frequency, the average, and so on and so forth. You can see the last one is the RMS value. At the lower right corner of the waveforms, this is the RMS value, which is currently is about 1 volt RMS. For me now, I just need to get the value that I want, like the RMS value, the frequency, probably the period, and this is cool, you know. I don't have to do anything, just choose the right value that I want. Isn't it that cool? What do you think, guys? Well, ice is not so good, then what I can do is go to the what we call it the measurement magnifier, which is you can go to the menu and check the adva, which again a short for advanced. I can guess. If you click it, you will find here the channel A, which is in light blue, correspond to the color of the channel A waveform. And then you can choose the specific measurement that you wanted to magnify, like for example the RMS value, which is I'm interested, and also the frequency. And you can see that it can display on the oscilloscope with the bigger font, easier to read them, and that's really cool, you know, good for poor eyes like me. I'm not wearing my eyeglass right now. Of course, you can choose some other parameters like the peak-to-peak value, the period, so on and so forth. And you can arrange them for a better viewing, like what I'm doing it right now. So you will have a better viewing for the right magnitude you like to emphasize. There is only one problem using the measurement magnifier, wherein when you minimize the application, then the magnifier stays there. It just can't minimize it. It remains in its position on the screen. That's probably a bug, I believe, that can be fixed. It's not a big deal, but just worth mentioning here in case you will be surprised if the magnifier values are stays there on the screen. Well, guys, are you following me so far? So good? Well, assuming that I don't want to do the automatic reading and I want to do it by myself, then what you can do is to enable the cursor. So you can click this icon, and then there are gonna be several cursors in the time division, and also in the volts division you can see those cursors. And it would be good to use the cursor without the grid, so I can turn off the grid by clicking the grid icon like this, which now is much cleaner and much easier to see. Let's see first in the time division. So I can move this cursor in here. This is called the cursor A. Let's see the frequency for a complete cycle. And I want to put the cursor A position in the zero crossing point of the sine wave as a baseline, or that is called the 0 volts. And then the cursor B will be on the end of the first cycle at the same crossing points. Again, that is the baseline at 0 volts. This is actually one complete cycle, so the position of cursor A and the position of cursor B is basically one cycle. And now you can read the frequency, which is already displayed there, which is about somebody say me, it is about 1 kilohertz. You can see also the other three cursors to measure the other point in the waveform. Let's try cursor B to C, for example. And this is how to place it. Then this is how you read it at the most right of the cursor. It is about I can read here 512.884 microsecond at 1.933 kilohertz. I think my position is not correct. That should be like about 2 kilohertz, but 1.933 kilohertz is very close to 2 kilohertz. So you can see right now that it's pretty good to use the cursor if you don't believe the automatic acquisition and reading. You can also use the cursor for the DNE, which is also a complete cycle with a frequency of 1 kilohertz, because you know the cursor A and B and the cursor DNE is basically the same for one complete cycle of 1 kilohertz. That is sine wave. Really, it's good to be at the comfort of my apartment. It's warm and silenced, like I'm just alone in here. In fact, I'm alone except for this. All right, let's enable the function of roller by navigating in the icon, and you can see at the bottom there is a roller in here. So this is the zero crossing point, the time base going to the positive, then crossing again, going to the negative. So I want to have this full cycle in here, and I'm going to make use of the roller, and I'm going to start that one position to 0, and then I'm going to exactly touch the bottom of the sine wave, and then I'm going to put this at the 0 crossing to have a one complete cycle. This one is a peak to peak. This point here is the positive one, and this is the negative one. So combining all together, this channel A 3.010 volt is a peak to peak of the AC signal. That is a sine wave. And if you can see in here, the peak to peak value is about 2.991 volt, which is very, very close. And from here to here, the starting point of the sine wave to the end point of the sine wave per one complete cycle, it takes about 1.007.157 microsecond. And how I'm going to validate that? I need a cursor in here, so I enable the cursor and then put the cursor at exactly where the roller started, and then this is the B, and I'm going to complete that for 1 full seconds. And there you go. So the roller is reading the time base to be 1007.157 microsecond, that precise. And what about the cursor? It is also reading as 1004.601 microsecond. It's very, very close, probably just my position on the cursor, so something like that. That's exactly 1007.714. Is just a little bit of the position of the cursor. If I'm going to take a look at the what do you call the advanced reading, and then I'm going to take the period, it says that the actually period automatically is 1000 microsecond, but I'm reading here is about 1007 microsecond, which is very, very close because I'm doing it manually. That could be some variations and error. The software basically is equipped with a full screen, and to enable that, click the F full screen. That's self-explanatory, and it will go into a full view screen. And to go back to its original form, you press the F once again. And we know already the grid, which is this icon in here. If you don't want a grid, just click it and the grid will fade away. Another one is if you have uncomfortability on your eyes, if you hate the black background, you can actually change the background into white, and then there you go. It provides a white background. It's the opposite of black, and you have a brighter background. Actually, it's irritating to my eyes, frankly speaking. If you want the black background, once again, just click this icon, click it back, will be white background. So it's like a toggle between black and white background. That's how you do it to make a better viewing based on your preference. There you go. There you go. Another one is the zoom function. If I'm going to click that one, it zoom in. So what it does actually is that you can zoom in the signal, click it, and then drag the mouse and make an area to zoom by using the right mouse. Click it and hold it, and then position that where you wanted to have that area, and then release it, and it will going to increase the amplitude as well as the time base sounds like that. And if you want to go back to its original waveform, you just click this one. There you go. It's so easy. There is another way to zoom in, like here. This is the same thing, but it will not going to increase the amplitude. It's only the time base. So if I'm going to zoom in the one cycle in here, so you can see that the amplitude is a constant and only the time base is changed. And if you're going to zoom out little by little or step by step, you have to click this icon in here until its original form. Of course, you can go and click this one once again to go back easily to the original form. And of course, there is an easy way to do that, to contract and retract. There is the zoom in and zoom out by using this slider in here. So you can see the waveform right now. Need to do that if you don't want to use the zoom in and the zoom out. And you can see also in here that if I'm going to stop the device, you can actually, this is just like put it into storage, stop the device, and you can actually here, if you can actually scroll down the storage signal, and then you can choose assuming this is a varying signal, not a sine wave, so it can actually store the signal into its memory. And of course, you can still build a function like zoom in with amplitude and the time base. So those are basically the super basic measurement capability of the OSC482H oscilloscope, the software and the hardware plus the audio generator. And as my finale, I would like to demonstrate about the use of two channels. So I'm going to remove the test right now. By the way, that is the OSC4, which is also from Loto. This is a 4-channel oscilloscope. I'm testing it for a day already. I'm gonna get this from the signal generator with the square wave output, and I'm going to put that into channel B. Oh, it's a little bit difficult. Okay, there you go. Nice one first. And then what I'm going to do is to enable the channel B. And I can see the signal for the channel B already with the oscilloscope. And I can adjust the position of channel A and also the position of channel B. So it sounds like that. I can actually stop it and goes into the storage mode. And there you go. Two channels, channel 1 or channel A, and this is the channel B. Then I can actually make some measurement right now. Go to the adva, and then VRMS for channel 1 and frequency for channel 2. I have to start it to acquire the signal. This is, you need to open every time and go again to ADVA, and then I'm going to choose the VRMS and also the frequency. So the yellow one is for the channel B, and for this color in here, which is I think that there should be a blue one in here, so that it will denote channel A, which is the blue color. That should be the correct one actually, because to be uniform, you need to put a color for the blue one in here, like the one they have it in here for the channel B. The color of the signal of channel B is yellow, and also the acquisition data or the automatic data for the measurement magnifier is yellow, and for the B there's nothing. It's just like a dark brown. What is that? Is it brown? My eyes is not so good right now, but I suggest that they should have also a blue color in here to denote that this is for channel A. You've seen it? Is that a fair assessment, guys? You think so? It's a fair assessment? Should be right. I want to put this one, the channel B, to 10 kilohertz. So there you go. That's the signal for 10 kilohertz. I'm gonna stop that. You can see also that the reading is 9.959 kilohertz, which is basically almost 10 kilohertz. And that's how is the signal. Go for the full screen. Can start again. This is the problem with this generator, because whenever you stop and stop, you need to enable also. So you go back to the minimize mode. After you enable the signal generator, then you go to full screen once again. That's how it looks like. Guys, I think it's time to park, and this is gonna be the end of the super basic measurement capability of the OSC482, the hardware and its software. I think that there are more technique, more precise and a better measurement that is hidden in the user manual. I haven't read actually. I just have to navigate it by myself. That's how user-friendly is the software. But I'm still going to take a look at the user manual, because there are probably some special measurement that I miss it. Probably that something that I can learn, that I can implement it in here. And once I do that, I'm going to make another video, and then we'll do demonstration. And not only for the video demonstration, but of course in a real world application. Alright guys, it's really say goodbye right now. It's Ferdinand Dandy saying bye for now, and enjoy the DIY hobby. Whatever you wanted to do, just enjoy it.